Hey girls. So as you know, we've learned a lot of symbols, okay? And they actually matter in these questions, so we need to actually really know what they mean, okay? I also just want to let you know that symbol means the same thing as dash. It's just a matter of preference, okay? So let's have a look at these questions that I really want to go through. Question 4. It says the number of pets X owned by each student in a large school is a random variable with the following discrete probability distribution. So what that means is students with 0 pets, the probability of choosing a student with 0 pets is 0.5, choosing a student with 1 pet is 0.25, and so on, okay? The tricky question part of this question is, if 2 students are selected at random, the probability that they own the same number of pets is, right? So before I do that example, let's go back to our head and tail situation. Let's say the question was, if 2 coins are tossed, what's the probability I get the same outcome? So we usually draw that diagram, but let's write the probability as well, okay? And notice how remember the probability never changes because it's just a coin, okay? So if this was a question, then obviously the answer is double heads and double tail, and then if I want to know the probability of both of them, you would obviously add them up. So in this case, head and head is half times half, which is, now I'm going to write it like this for a reason, a quarter. So this is for HH, and then for tail tail, same thing. And then so obviously the probability of getting if the probability of getting the same outcome from 2 coins is that plus another one, yeah? So this is the same technique you use here from a table. So in this situation, the probability of you selecting 2 students that both have 0 pets is 0.5 squared. Okay, that's the technique. And then you actually have to do that for the rest of them, because plus you can also have 2 students where both of them have 1 pet, so you do 0.25 squared. That's just like what we've been doing here. We square it because it's the same outcome. So the probability doesn't change. Okay, so this is a technique I wanted to show you girls, okay? So if they ask you for a question like that from a table instead of like a tree diagram, that's what you do. Yeah, so if you put all of this in the calculator, you'll get your answer. Answer is C. All right, let's have a look at question 5 now. In question 5, it says A and B are events from a sample space such that the probability of A is P. So I've written it down. Okay, where P is a bigger number than 0, it doesn't matter with that one. It says probability of B given A is equal to M, and probability of B given not A is N. Now here's a key word, A and B are independent. So they want you to basically in this question find the value of M related with N. Okay, so let's have a look over here and let's see what we should use. So we're given question and we got the independent word here. That means I want to use this property here. Okay, so let's look at it one at a time. And when I say that, let's have a look at this. Okay, if A and B are independent, okay, let's say I didn't know M. What's the probability of this using that? Okay, it's this or this. Yeah, just following that. Now, this and that are both equal to M. Okay, so that's the technique here. Let's do the same thing here. So if I bring it here, let's say I didn't know N. That means the probability of B not A is equal to that or that. Okay, and they're both equal to N. And then what you do from here is, can you see what the answer might be? Probability of B, okay? So what does that imply? Okay, that implies these two are the same. Okay, so the answer is A. So that's how you do that question. So in the end, really, we didn't even have to use that. So that's what makes this question tricky, because you got to use one of these, or at least memorize it, because these aren't in your formula sheet. Okay, girls? So you need to practice it. The discrete random variable x has a distribution as shown, the median of x. Okay, so we haven't actually done a question like that. So they want you to find the median from this table. So this is how you look at it. Instead of 0.4, this is 4 over 10, yeah, as a fraction. This is 2 over 10, 3 over 10, and this is 1 over 10. Think of these numbers, the top numbers, like your frequency, okay? So if I wanted to find the median, right? Remember, you get the total frequency divided by 2, yeah? Because frequency is the number of scores. So if I do all of these numbers, it's obvious it's going to be 10. So if you do 10 divided by 2, that's 5. And because your total frequency is even, that means going back to year 7 and 8 data, your median is in between the 5th score and the 6th score. Okay, so that's what you need to be able to locate from here. So where does 5th and 6th score lie? It's actually they're both over here. Can you see that? Because the first 4 scores are 0, and the next 2 scores, which makes a total of 6 scores, is 1. So your 5th score and your 6th score are both 1. So because they're the same number, the median is 1. So that's how you do this question. So the answer to question 8 is B. Alright? Okay, now let's get into some tricky questions. A and B are events of the sample space S. The probability of A and B is 2 over 5. The probability of A and not B is 3 over 7. What's the probability of not B happening given A has occurred? So that's the question. Okay, so to start off with, because it's a given question, let's write down the formula for this using what we've learned before. So on the top, remember, you always need the probability of B and A. Yeah, remember? The and goes on top and the second one goes at the bottom. Okay, so we need to work with that. Now this one, the top, that's actually the same as that. It doesn't matter which order you write it. So we have the number for top, okay, over, but we don't have the question and answer for A, okay? So we need to figure that out. So the way to figure it out is by using these two, okay? And here's how. So here's how I want you to visualize this. It's a Venn diagram, all right? So if it says A and B, obviously that's the number in between the scores. But if it says A and not B, this means only A. So let's say this is the A circle, this is the B circle, that's your A and B. Then that means just strictly A number is 3 over 7, okay? So that means if I wanted to find the number for A, that's all of the numbers under the A circle right here, which means this plus that. So that's how you get that number. All right? So this is what you need to put in the calculator, okay? Just B, okay? Let's apply similar technique in question 10. For events A and B, the probability of A and B is P. The probability of not A and B is that. Probability of A and not B is that. A and B are independent. Find the value of P. Okay, so to start off with this question, the word independent is quite important. So what do we know about independent? Let's go back to the other side of the board. All right, so what we know so far, if it's independent, we know this. We know if it's independent, it's that. Obviously, we don't want to use this one because we don't have a given symbol in the question. So let's go with this. Okay? Okay, that's our starter. And as we know from here, because we're given this, we know this is P. Now our task is to find these two because we don't have that, but we'll use that to find those. So, girls, remember this means not A and B. So that really means here, only B number is that. A and not B means only A. So let's apply what I've done there in the previous question here. So if I drew, remember this is your AND number, so that's P. A and B is P. Let's say this is your A, this is your B. Only A number is that. And only B number is that expression. So if I wanted to find the number for A, remember that's all of the terms under A, which means 3P over 5 plus P. And similarly, now remember these are multiplied, PB would be that plus that. Plus P minus 1 over 8. I don't have to put in a bracket because minus takes over that. Alright, so as you can see, we've got quite a long expression to work with. Okay, 8. Okay, bring the 5 to the other side. That's 5P is equal to 8P 2P minus 1 over 8. Let's expand this. 5P, 6P equals to 0. You should know what to do from here, obviously. So factorize it, and then you should be able to get P equals to 3 over 8. Okay? So that's how you do this question. So the answer is C. Quite a tricky question, as you can see. Alright, let's have a look at question 12 now. Events A and B are mutually exclusive. So once again, two events cannot occur at the same time. Okay, and then it says P of A is P, P of B equals Q. What is the probability of not A and not B? Okay, that's the question. Now, I want to make one thing clear. You know how on the other side of the board, actually I wrote it here, see how P of A and B equals to that times that? You can't use that for this. So I just want to make it clear, this does not equal to P of not A times P of not B. That doesn't work, okay? I tried it with actual numbers and scenarios, so don't assume you can use that for not A and not B as well. It doesn't work, so keep that in mind, all right? So, in order to do this question, you actually got to understand what they're asking. So I want to go back to what we did in the previous chapter. Let's say I have 5 blue, 3 white, and 7 yellow marbles. If I asked you, what's the probability of not getting a blue marble and not getting a white marble? Doesn't that just mean probability of getting yellow marbles, which is just 7 out of, in this case, 8 plus 7? It's just that, right? So that's how I want you to view this question, okay? And at the same time, remember, mutually exclusive event is when you can't, two events cannot occur at the same time. So marble selection is a mutually exclusive event because you can't pick blue and white at the same time in one marble pick. So here's how I want you to view this. This is the same thing as writing, or if you do one takeaway, blue plus white, that's the same thing as 7 over 15, isn't it? Because if you do 1, that's a total, take away the other rest of the colored marbles, they'll give you yellow, which is not blue and not white. That's how I want you to view this question. Not A and not B is the same thing as me saying 1 take away the total of P and Q. All right, so that's how you do this question. That's 1 minus P minus Q. Okay, oh sorry, that's just C. Okay, so yeah, tricky question. All right, question 15. Okay. Consider the discrete probability distribution, blah, blah, blah. The table is given, okay? Now, the smallest and the largest possible value of E of X are respectively. Okay, so in order to do this question, here's a technique. You have to take 2 cases. From the table, what's the biggest value for A you could have? So in other words, from the table, what's the biggest value we can give for A if B was 0? That would be the biggest value you can give for A. can you see then the biggest value would have to be 0.8, because remember all the numbers has to add up to 1, and currently in the table we have 0.2. So 1 take away 0.2 will give us 0.8. So what you do, so you let a equals to 0.8, b equals to 0, and then you find e of x, which you know how to do. So I won't go through that. I'll just take this as a guide for you girls. So this is your first scenario. Second scenario, what's the biggest value for b possible? A equals to 0. What would the biggest value for b be? Well, how many b's do we have? We have b, b, and 2b. That means 4b equals to 0.8. Yeah, remember? Because 1 take away 0.2 leaves 0.8, and I have 4 b's. So assuming b is 0.8 divided by 4. Okay, so substitute this, and then find e of x for both situations. Okay, so that's how you would do this question. All right, last question, girls, just the guide. All right, I'm just going to quickly rub off. Question 16, a car manufacturer is reviewing the performance of its car model X. It is known that at any given 6-month service, the probability of model X requiring oil change. So I'm just going to write, sorry, what question am I doing? 16. Oil change, so the probability of oil change, so I'll write it as that, is equal to 17/20. And then the probability of X requiring air filter, so I'll just write probability of air is equal to 3/20. And then the probability of requiring both, so let's say O and A is equal to 1/20. Okay. State the probability that any given 6-month service, the car will require an air filter change without an oil change. So once again, if it says probability of air filter change without an oil change, that means only A. Okay. So once again, if it's a situation like that, Venn diagram. So let's say that's my oil, that's my air. We know the number for that, 1/20. Probability of oil, that means all of the numbers under O is 17/20. So that means this only oil must be 16/20. Yeah, does that make sense? 17/20, take away the 1/20, 16/20. Similarly for air, that's for everything inside the A circle. If I want only air, which what they're asking is just 3/20, take away 1/20, which is 2/20, or 1/10. Okay, so that's how you do that question. Use that same technique to do question B. All right.